Good. So I'd like to welcome you to our SIA webinar, which is intended to be a CANopen FD update. I like to share with you some latest developments in the area of CANopen FD. My name is Rainer Sitzmann. I'm the General Manager of Canon Automation, and I'm guiding you through this SIA webinar. I hold a degree in electrical engineering from the University Erlangen-Nuremberg. And besides managing Canon Automation Office, I represent Canon Automation in some international working groups, for example, in the TC69 WG10, the project leader for the CANopen communication to accompany the power transfer between a light electric vehicle and supply station, supply infrastructure for the CANopen communication, to double check that everything is going well there, that no dangerous situations occur for the end user. So this had been one project. Another project had been introducing CANopen standard in the railway business. So you have typically a hierarchical approach in rail vehicles, where you have train communication network and vehicle bus level, and on the vehicle bus level, we integrated CANopen, one of the, would say, comprehensive CANopen specifications that we have. Not only the basic CANopen specification included there, but also network management, access from outside, redundancy, and so on. Furthermore, I accompanied the standardization process of CANopen in the application field of garbage trucks. So there had been a standardization project for standardizing how the different subsystems that are mounted on a garbage truck application interoperate, exchange data, and also here I accompany the standardization process for the communication interfaces for all those subsystems mounted on such a truck. Of course, all these international standardization projects have several mirror groups on European or national level, and also here I represent Canon Automation and try to represent the interests of the Canon users. For those of you that are not that aware of Canon Automation and want to know who is Canon Automation, what is Canon Automation doing, Canon Automation, or briefly SIA, is the international users and manufacturers group that develops and supports CANopen and other CAN-based high-layer protocols. The non-profit group has been founded in 1992 to provide CAN-based technical product and marketing information. The association fosters the image of the CAN technology and provides a path to future network technologies. So we do this since 1992, as you can read, and we try to establish since these days a huge social network. And you, as a member of Canon Automation, or also just as a member of the Canon community, you can benefit from our work, from the establishment of the social network, as if you have to overcome some challenges in your Canon-based projects. One solution could be you contact Canon Automation Office. You find here our contact data. We are located in Nuremberg, in Germany. Give us a phone call, write us an email, use our social media channels, contact us, leave your questions, and within 24 hours at least, we try to assist you. Maybe we can help you directly, or at least we can rely on our social network that we have established since 1992. And maybe there we find somebody who is tailored on solving the issues that you have in your projects, and we can direct you to this company, and you can accelerate with your project. So don't underestimate the contacts that you can get by joining Canon Automation, or at least being somehow a member of this CAN network that we have organized since 1992 on a social point of view. Yeah, brief history to Canon Automation. Canon Automation has been founded in 1992. You see here the founding members: Berghoff, ESD, Geiser, Jün, LP Electronic, MEN Technology Partnership, and Mr. Holger Seltwanger, who is since these days the managing director of Canon Automation Association. So Canon Automation tries to promote CAN, so therefore We publish quarterly a magazine, the CAN newsletter, where we inform the CAN community about latest developments and movements in the application field of CAN. And furthermore, we try to figure out what are relevant fairs. We go to these fairs and inform the public why is it reasonable to use a CAN-based solution in this application field, what are the advantages, where are suppliers, where are maybe some reference projects. So I can, as a potential user, do my assessments and evaluate and think, well, is for my application CAN the best choice? So we do this globally. So we had activities also in Asia, in America, to assist people in using CAN and to get the latest knowledge about CAN-based networking. On the other hand, we figured out rather early that just the CAN specification is not sufficient to develop independently from each other interoperable or even interchangeable products. Some additional specification work is needed. So for example, which kind of physical layer shall be used? There exist various physical layer options for CAN, which one shall be used in a specific project and which way. For example, which kind of connector shall be used. So something like that, you have to specify for a project where several vendors supply, and therefore we need some additional specification. And we as CAN Automation, we provide you a neutral ground where you can meet with others and can make these kind of specifications. The result is then a CAN Automation specification. And one of the first one had been the document 102, where we specified how you can use CAN in an industrial environment. The specification 200 had been a first idea of how to use the CAN frames. You can use the CAN frames in either way for configuration data, program data, and so on. And the specification 200 series gives you some idea how to use the CAN frames, for which purpose you can do it in a common way in a multi-vendor project. And from time to time, we organize also CAN conferences where CAN experts can come together and can exchange their information. Which kind of challenges have they met in their project and how can we overcome them in a harmonized way? So you see, CAN Automation is also doing some specification work, some maintenance of specifications. The CANopen specification had been handed over to CAN Automation for maintenance and further development. So we do this. And in 2012, Bosch presented on an international CAN conference the CAN with flexible data rate. And we have accompanied the standardization process of this CAN FD. And furthermore, we have evaluated together with our working group, the interest group CANopen FD, how we can use the famous CANopen on top of CAN FD data link layer. And the result had been the CANopen FD specification CR 1301 that we have released in 2017. And the history of CAN has not been written yet. We are still writing on it. So currently there's a standardization project running, a specification work running on a next generation of CAN. It's called the CAN XL, and the project started end of 2018. And we are rather at the end of this project, and we hope by end of this year we can start international standardization for CAN XL. So that you see that still a lot of people are interested in CAN. A good idea became by our members. So we have a constant growth of CAN Automation members. At the beginning of the year, we had 703 CAN Automation member companies that think CAN is still a good choice for their projects, and that being part of the social network offered by CAN Automation is valuable for them so that they get the latest information on CAN-based developments. So the activities of CAN Automation, they are steered by two committees, by two steering committees, the technical committee and the business committee. The technical committee says, where is CAN Automation going to standardize something? Maybe is initiating some standardization projects or accompanying and hosting them. And you see, we have there several interest groups where people need to maintain, for example, the CANopen specification. It's the IG CANopen. to develop and maintain CANopen FD related subjects, it's the IG CANopen FD, or to maintain J9039 based issues and to deal with them. So this is the IG J9039. As we have now some groups dealing with different communication techniques, we have to think about what if they are standardizing the same issues. So for example, how does an I/O module arrange the data and communicate it via CAN? Why should we describe this in a different way for CANopen FD, or for J9039? So device developers could benefit if the way the data is arranged within such a device, such an I/O module, for example, would not depend on the communication technique we are using to transfer the data. So we installed another group, the IG profiles, defining the databases for the different applications. So for example, for I/O modules, drives, elevators, and so on. And the different communication groups, they can now map this data to their communication technique and define how to communicate this data by using this corresponding communication technique. At the beginning of last week, we had a meeting of the technical committee, and there we introduced a new interest group, the interest group High Availability, dealing with redundancy subjects. So for example, bus line redundancy issues. How can I set up a CAN-based systems with different communication lines, one active line and several redundant lines? And how can I figure out which one is the active one, which are the redundant ones, how can I switch over? And this in an independent way. Independent means not depending on the used CAN-based high-level product. And furthermore, we have a working group, it's a working group Safety and Security. And just yesterday, I got a request to install a working group, a CANopen cybersecurity layer that allows dealing with cybersecurity issues in a harmonized way in a CANopen environment. So you see, these are our working groups, and if you're interested in, you can just ask me, write me an email, or later on in the Q&A, I can come back to this. Just a final remark also with regard to the slides that are upcoming. So Canon Automation has committed itself to the inclusive language. So as you see here, among others, we had their decision on terms that are also used in the CANopen environment, such as a master application or a slave application, and we are going to substitute them. The master is more or less substituted by the term manager, and the slave is substituted by the term server in the applications where it's applicable. So, for example, in the layer setting services, we are talking now about managers and servers, or the same for network management. We have one network management manager, and the devices are called those with the server functionality. So just that you know that we are currently shifting our terminology, and this will affect also CANopen, although the slides I'm using today are maybe not totally switched over and adapted as it had been this decision just last week. Furthermore, we have another steering committee. It's a business committee. The business committee is discussing for which projects we are spending money. We are allowed to do some invests. And here you see, if you're interested in, we are planning also some additional marketing functionalities with regard to our CANopen FD, for example, with regard to the SPS fair, which will hopefully take place end of this year in Nuremberg in person, so that we can meet once again the people, the CAN users that are interested in CANopen, and we can discuss how to switch over from CANopen to CANopen FD maybe. Yeah. For the rest, I think as you know, more or less nothing has changed. We deal with the specifications. We are serving as an unbiased platform. So you can come to us, you can generate with your partners some specifications to run multi-vendor projects rather smoothly based on CAN and CANopen. We do for these activities some marketing and assist you in a technical way by seminars, consulting services, testing services, and so on. Also with regard to my talk now, we had last week an international CAN conference. The international CAN conference was a pure digital one. We generated a lot of videos. We have the proceedings available. You can still purchase them. You can still get access to the videos. And it provided us also some updates to CANopen FD. And I will talk about some things that came up during this international CAN conference that you got an idea of which subject CAN automation and the CAN community is working with regard to CANopen FD. Furthermore, to get the latest news, I'd like to remind you on our publications, the newsletter, online magazine. So there you can get latest updates as well as our email services. So much for the moment. I think this you can read by yourself if you want. And finally, we are starting with the subject, the update to CANopen FD. So in general, by one of the previous webinars, we have already introduced CANopen FD. We have already informed you what is CANopen FD. It is a way how we can make use of the data throughput and the advantages provided by the improved data link layer CAN with flexible data rate from the position of an updated, enhanced CANopen application layer. And the name for this had been the CANopen FD application layer and communication profile. It had been released in 2017 by Canon Automation. It had been developed within the interest group CANopen FD. And rather soon, we saw first CANopen FD protocol stacks that had been also shown on the fairground and the embedded at the SPS in Nuremberg. And furthermore, we saw first devices in 2018, 2019, or at least some prototypes, up to some gateway applications that allow transiting from CANopen to CANopen FD. So when we're talking about CANopen FD according CR 1301, we have in mind that we have a CAN-FD physical layer, a CAN-FD data link layer, and on top of this, we are running a CANopen FD application layer that is capable to use the CAN frames in the way as it is defined by CR 1301. So you see here the CANopen FD device model. So this device is a little simplified model, but it's more or less identical to that what you may know from classic CANopen. You have a field device. From this field device, we have a CAN-FD device. It's more or less our CAN controller, CAN-FD controller, where I adjust the bit rate. And from this CAN-FD device, my CANopen FD device inherits the bit rate. We have now two bit rates with which we have to deal with, the nominal bit rate and the data bit rate. The data bit rate, which is used during the data phase while communicating the CAN-FD frame. And then we have our CANopen FD device, as I said, rather similar as a classic CANopen device, but we see here a small difference. We have here a network ID. In addition to a node ID with which you may be familiar, we have now also a network ID. Also in a CANopen environment, if you use the extension 302-7, you have learned they exist also in the CANopen environment already network IDs. Here we have taken over this functionality in the basic CANopen FD specification 1301. Also for classic CANopen, we find the description of an NMT master. In CANopen FD, we call it now an NMT manager. And this NMT manager is now at least in small parts already addressed in the basic CANopen FD specification 1301. All the rest is rather identical to that what we have already had in CANopen and classic CANopen. And to remind you a bit, on the data link layer, we have a CAN-FD data link layer. This means we have now in CANopen FD the option to transfer CAN-FD data frames with a data payload of up to 64 bytes. And if you like, we can transfer the data field in an accelerated way, depending on the bit rates specified by CANopen FD or some additional ones. So using these data frames, having the capability of to do so is a must in CANopen FD, but we will learn later on that also in the CANopen FD environment, at certain times, we will have the need to switch over to classic CAN and to use classic CAN frames, for example, to do something that is known as node ID assignment by means of layer setting services. But for the moment, we see here the comparison. We see the classic CAN frame in the upper part with up to 8 bytes of data that we can communicate, and with the lower part with up to 64 bytes that we can communicate in case of doubt in an accelerated way. With regard to the lower layer, CANopen FD provides us with some additional specifications. CANopen FD specifies pairs of bit rates to be supported by any CANopen device. I can use additional ones, but to achieve more or less out-of-the-box interoperability, CANopen FD provides us with a specification of these bitrate settings. These bitrate settings are based on 80 megahertz. Currently, we are extending the specification for bitrate settings based on 40 megahertz clock. So this seems to be more appropriate depending on the availability or having in mind the availability of CANFD hardware. Furthermore, system design aspects are not covered by CA 1301. Nevertheless, has system design a big impact on the achievability of certain bit rates. Therefore, you should consider also the CA 600 series. You find there a lot of valuable information on device design, on system design, and also during the International CAN conference that we had last week, we found there a lot of presentations dealing with CANFD physical layer issues that you may have in mind as well when you're working with CANopen FD. So maybe something that could be of interest for you is the presentation from Tony Adams, who gave us some ideas on CAN signal improvement and designing 5 Mbit networks. So how can I achieve a network architecture running with this speed? So the key of this presentation was that you have to consider the usage of so-called signal improvement circuits. So these are CAN transceivers that can stabilize the signal and provide you a clear signal, a voltage level over the bus, calm down the ringing so that you can guarantee that all the devices in the network do really detect the right signal. In a similar direction goes the presentation from Kent Leonardson, who talked about improved CAN drivers. So he was playing around with the slew rate, and this is more also if you are avoiding the bitrate switch, because when you're bitrate switching, I think the slew rate is more or less fixed. But when you have a flexible slew rate and you run lower bitrates, which you can also do with CANFD, then you can play around with the slew rate and you can calm down the ringing and avoid to put in too much voltage. And therefore, also you can allow other topologies or more challenging topologies. Also of interest could be the CAN physical layer options that had been presented in a webinar by Magnus Maria Hell. So he's a very good physical layer expert. And I think if you want to dive more deeper in the topic CANFD physical layer, then you should listen to these considerations. Finally, we have 2 working groups, the Task Force Signal Improvement, that had accompanied the development of the SIG transceiver, the Signal Improvement Transceiver. And furthermore, I like to remind you there exists something that is called a SIG CANFD Lite specification, or a SIG CANFD Lite controller. What is the project about? It goes directly about, or deals directly with light control. So if you think about modern cars, they have hundreds of LEDs to control, to bring the right light patterns. And to control this, they want to use FD frames because of the length of their payload. And then you have one controller and all the rest of the devices, they are not really controllers. They don't need really a CPU, but they are more or less extended IOs, and they just take the data and do some on-off switching of the corresponding LEDs. And what this or how this is done, this can be maybe several low-performance applications of high benefit. So if you're interested in these activities, then give me an email or a call, and I will provide you with some additional information. And also, you see here, Fred Renning from ST Microelectronics informed us about this. And I think this can be also for some CANopen applications of high interest. When we had a first look on the CANopen FD device model, then we figured out that we have, in addition to a node ID, now to deal with a network ID. So every CANopen device, FD device, has a node ID and a network ID, and a preferred method of ID assignment has not been defined. So as now for classic CANopen, several methods are applicable: local switches, geographical addressing, and whatever. And furthermore, we have the layer setting services. So also in the classic CANopen environment, layer setting services are of high interest and often or more and more used in projects, because projects need a certain degree of dynamic behavior. Maybe the end user has to exchange some devices, has to plug in some new instruments, has to maybe at a dentist chair, the dentist, or maybe at a Pedelec application, the user wants to change the batteries. And you have now to treat this new device, maybe this new battery that had been attached to the application, and you have to hand over, for example, some addresses such as a node address or network address. And basis for layer setting services are the information hosted in the so-called identity object. It's the object 1018, introduced and mandatory in classic CANopen, but applies also for CANopen FD. So the vendor ID, as it's written here, is a worldwide unique number assigned by Canon Automation. And the vendor ID applies in the CANopen environment as well as for now in the CANopen FD environment. And it describes you as a unique manufacturer worldwide. And in the switch state selective command that is specified in CR 305, the classic CANopen layer setting services, you say via 4 data frames, the device of this vendor with this product code, this revision number, and this serial number shall go into a configuration state so that I can hand over a new node ID. So the use case is that you have maybe several devices, maybe from the same vendor, and they, in the worst case, just differentiate via the serial number. And you have now to differentiate between them via this protocol to pick exactly one of these devices, and then you switch to another protocol and hand over the node ID value. Now, in CANopen FD, we have much more space in one telegram. In CANopen FD, we have the option of 64 byte to transfer in one telegram, and therefore we can optimize this switch state selective command. And you see here on this slide, the LSS switch state selective command for the FD environment. And in CANopen FD, we have now the document CR 1305, the option to transfer the so-called LSS address composed of vendor ID, product code, revision number, and serial number in one telegram, here indicated as portion. And we have some additional control, space for some additional control information. And this means I can also figure out or think about new detection mechanisms that I can say, I propose a certain part of this so-called LSS address and ask, therefore, is there somebody in the system that equals with its LSS address to the proposed pattern of the LSS address I'm proposing by this protocol that is now shown on the slide. And you see here, you propose maybe a certain subset, therefore a portion of the entire LSS address. And you ask, okay, do you maybe, does your LSS address, or is your LSS address identical maybe to the first three nibbles of your LSS, of the LSS address I'm proposing here in the portion field? So I give you some meta information, which nibble we are currently analyzing. I give you some timeout value, how long is LSS manager waiting for answers. And then all the devices in the network, they can evaluate, okay, do I follow this proposal? Yes, no, okay. My LSS address equals to the proposed pattern, and then I give the information, okay, I'm here and I match to this pattern. So you can detect in this direction, or you can search in this direction furthermore till you have identified one unconfigured device. So this is the use case of this protocol. You have there 3 or 4 devices from the same vendor maybe inside your system. You plug them new to the system, and now you have to assign them from the perspective of a host controller an unique node ID value, and you have to differentiate between these devices. And while this protocol, you have the option, and to accelerate in contrast to the classic fast CAN service that you may know from the CANopen environment, the LSS slaves, or now called LSS servers, have now the option to inform the manager about the value of the next nibble they would have in their LSS address. So the LSS manager is no longer blind and has no idea how could the value of the next nibble of the attached devices be. They inform by themselves how does the next nibble look like. And to overcome some limitations provided by CAN, we are using some CAN functionality, the Bitwise Arbitration. And you see the formula first time here, that you say, we are using for the response, if the first nibbles are matching that are proposed, we are using for the next evaluated nibble offset value of 7DO plus the value of my next nibble. And this I provide. And now the manager gets an idea, okay, in which value range it is worthwhile to analyze. Are there some further unconfigured devices till he can assign a node ID to a detected device? So you see here how this is done. We are proposing already maybe known value that we know, okay, at least in this value range, we know there are some devices starting with a 0, 0, and the next nibble is the 6. And I'm analyzing now the third nibble. Now all the devices can compare. Does this match? Yes, up to this is match. Now the analysis is about nibble 3. Then they provide the next value, maybe in this use case, the D as a value of this nibble. And by using the protocol as explained on the last slide, the request from my manager and all the servers analyze, and if the first nibbles are matching, then I provide the answer 7D is 0 plus the D, and I answer with this CAN identifier, and therefore by analyzing the CAN identifiers of the responses, the manager knows, okay, where residing my devices. So it's important to notice that we are using for this the classical base frame format. In FD frame format, this would not work with the response because there you have to consider the EASY bit, the error state indicator, which may cause troubles in this application. Therefore, we have to stick with the classic base frame format. More details on this you can find in the presentation from Ms. Yao from Canon Automation. CANopen FD device identification via new or updated LSS services she presented there. You can analyze the latest work draft, CR 1305. This is, I think, almost finalized and will be released soon. And also during the ICC, we had a presentation of an alternative method or an extending method by Mr. Philip from Emotas Embedded Communication. And Mr. Philip provided us a theoretical approach for node ID negotiation in CANopen networks. It works more or less, or rather similar to that what I presented here from the LSS FD. The only difference is that he is using a 29-bit identifier so that he can propose not just nibbles or inform not just on a nibble base, but he can inform about the next byte values. So therefore, he can further accelerate. The trade-off is that he has to use a 29-bit identifier instead of an 11-bit identifier. So, but it has at the moment, as far as I understood, not yet a practical use case, so there are no implementations with regard to this available, but he said he will submit this proposal to the LSS group, to the group that is dealing with the document 1305, so maybe we get an update in this direction. As I said, if you are interested in this, you're very welcome to join these activities. So if you started up our CANopen FD device, we will figure out the new services. So as I said, we have presented them already in some webinars. I will not emphasize them too much. I just showed you that we have now means for adjusting a node ID and a network ID, and that we consider in CANopen FD also formerly called master, now manager functionality. You see here the lineup of our services, and there we see on the one hand, we have the lengthened PDOs covering 64 byte, and we have the very powerful new universal service data object that is enabled to set up dynamic cross-communication channels between the devices on demand, and provides us a lot of communication capabilities. In addition, we have an emergency protocol, an updated one that provides us much more error information than in the past, the comparable classic CANopen service. All the rest we kept stable, so special purpose protocols such as sync, timestamp, network management, boot up, this was kept stable in comparison to classic CANopen. You see here brief insight, the emergency write protocol. If you have a detailed analysis, then you see, hey, with the emergency error code, the error register, and the device specific field, this is exactly the former emergency message you may know from classic CANopen. In addition, we provide you some status information about this error. Is it maybe a recoverable, a non-recoverable error? We classify in which specification is this error code defined. And furthermore, if we're talking about much more complex devices, we provide you the information which part of the device is really affected from this error situation. Finally, we give you an idea about the timing so that you can bring all the errors that occurred in the chronological order. For that purpose, we have a timestamp. We can record these errors in a new error history, and we have therefore a management object for this error history domain, which can, over the device lifetime, depending on the provided memory resources, store all these errors, and you can manage this by saying, I want to delete this or that error class, and I want to keep other ones. So therefore, you have this new object, which we have already presented. Important for all those coming new to CANopen FD, I think, is the lengthened PDO. You can use the well-known mapping mechanism and PDO description, as you may know from classic CANopen. You have your mapping table, you have your communication parameters, defining the CAN identifier and the data. And now the only difference to classic CANopen is that the threshold value for filling up the data field is now increased from 8 to 64 byte. A little bit different, this is for the universal service data object. The new update to the SDO, the old SDO has been removed and substituted by this service. It comes with a full function coverage of the classic SDO, but a lot of extensions. So for example, We can now establish dynamic cross-communication between the devices. We can communicate not only in unicast, but also in multicast and broadcast. We may have parallel access to the very same device. At the moment in classic CANopen, we had always to wait till an SDO access is finalized to initiate the next one. Now we can do everything in parallel. And furthermore, we have updated the abort codes to provide you with a lot of more detailed diagnostic information. And finally, we have many doors open to future extensions, for example, navigating through CANopen FD via browse names and so on. One major change in the CANopen FD USDO in comparison to the classic CANopen SDO is the allocation of the CAN identifiers. The CAN identifiers used in the USDO service are determined by the sender of the telegram and no longer by the server. There's a big difference. So we see here the request from client to server. Oh, sorry, there's a U missing. It's the USDO client. From the USDO client to the USDO server is the 600 plus node ID of the client, and the answer comes with the 580 plus node ID of the server. So always the sender of the telegram provides the CAN identifier. And this gives you this high design flexibility. Now you can ask, how can I know that this request is intended for me, that I have to answer this? And this is clear because the destination is coded within the data field. There we have the destination address in the first byte, and this destination address provides the information. Is this a unicast? Then I provide here a node ID, or multicast or broadcast message. Means everybody in the network shall deal with this request, or only a certain subset of devices. So for example, an ideal service for checking out who is in the network available, broadcast read to object 1000, and I get an idea on which node IDs can I expect some devices and which functionality resides there in the network. The command specifier allows me selecting the right USDO service. Session ID allows differentiation between several transactions between the same or several devices. Subindex and index, which data element in the object dictionary of the server shall be accessed either by read or write access. And another addition to classic CANopen, we have the ability to describe the data that is transferred via USDO, so in size and data type. So you see here the expedited USDO access. We have also others like the segmented transfer, the bulk transfer, but this is not subject of today, therefore just a reminder. Furthermore, you see, we always adapt the payload to the real needed one. In CANopen, in classic CANopen, we transferred all the time 8 byte data frames. We took the maximum payload lengths. Now we deviate from this and only transfer the real required payload. So, brief summarization to CANopen FD. So, as I've said, CANopen FD integration workshop had been the first one in October 2016 and had been demonstrated already at the SBS, and the specification available since 2017. So I have already informed you about this. I think of interest is for you the availability, that the stacks are available, first devices are available, although they are not really CANopen conformance tested, but this conformance test is currently under review. And furthermore, there exist also CANopen to CANopen FD gateways. Prototypes are already available by companies. You see here the listing, and current update you always get from our publications, such as the CAN newsletter. You may know that with regard to CANopen FD, conformance testing is obligatory. So the business committee from Canon Automation said every CANopen device, FD device has to pass the CANopen FD conformance test at Canon Automation office. So therefore, we are currently also developing a CANopen conformance test. What are the goals for conformance testing? Increasement of the reliability and increasement of the interoperability, of course. And therefore, the tests have to be reproducible and self-explainable so that people can prepare themselves, and on the other hand, that they can assess, okay, what should have been the result. What we are also doing are positive and negative tests. So we are not just evaluating, okay, this is how the request should be and is the answer correspondingly. So what we are also doing is, if we deviate with our request and our stimulations from the specified way, is then the behavior of the device still correct? How does the device handle this? Does the device indicate some errors and say, hey, there's something strange, so I go into an error reaction? Or does the device accept this? Also something like that is under evaluation, and the test results are then discussed with you as a customer and help you to improve the CANopen FD implementation. What about the development of CANopen FD conformance testing? So CR 1301 CANopen FD specification serves as a base for testing. The version 1.0 is released. We are working already on a version 2.0, but we have the base done for developing a CANopen FD conformance test plan. And it's a rather comprehensive work, but also here a lot of work had been done already. Furthermore, based on this conformance test plan, we can then give some tasks to companies to implement as automated tests, an automated test tool, as the test plan, which will serve as base for this work, has not been finalized yet. We could not do the bidding for the test tool and for the implementation of the test, and therefore this project, part of the project, has not been started yet. As there exist already implementations that claim being a CANopen FD device, we have to provide something for the meantime for what can we do from now until the moment that we have this automated test tool. For this moment, we can say, yes, we have already a kind of manual test. The checklist is provided on the CR website and approved by the technical committee. And here in CR testing laboratory, we are using this manual test for checking the key attributes of CANopen FD devices to guarantee on a low-level way that the devices are interoperable and working correctly. Of course, we see with the CANopen FD some testing, some challenges. So, you know, the USDO is a very comprehensive tool in embedded networking. There's a high function coverage. So you can assume testing unicast, multicast, broadcast in a local and remote way, testing these functions in parallel transactions, and furthermore, not only from a server, but also from a client perspective. So they're rather challenging things. Which exceed having just one tool and one test candidate, but you need an entire test environment with several devices. You have to differentiate when is it still a static conformance test or when starts already performance testing. So some of these cases described in the first bullet point depend a lot on the processing power in the current use case. And this, as I said, makes a certain assessment necessary, what to do in a static test and what to hand over to an interoperability testing or a plug test. We have also, of course, some challenges with regard to error recording. So how can errors be triggered in a use case comparable to real-life conditions to assess correct treatment? How does error recording management influence testing? So also these things have to be assessed, and then we can consider this in our test plan and then in the tool. But as I said, on the one hand, we are very happy that we have this powerful CANopen FD. On the other hand, it makes us some challenges to make a comprehensive testing available. But nevertheless, I think we're on a good way. Furthermore, we are also evaluating at the moment whether we should consider node ID adjustment and network ID adjustment in the testing. So it would be a common mean for adjusting node IDs, and it would ease, on the one hand, device integration, of devices if layer setting services would get obligatory. And if we consider this then in the testing, this would be also then a good thing and a big step forward, I think, in interoperability of devices in certain applications. When we're talking about CANopen FD device testing, we have also to consider electronic device description of CANopen FD devices. Also here, we did a big step forward. So the XML specification in the first version is released. So a kind of image of that, or a starting point for describing CANopen FD devices had been the already existing XML specification for classic CANopen devices. And starting from this, there was double checked, okay, what is really needed to describe CANopen FD devices, to have on the one hand the full coverage of CANopen FD, and on the other hand to get rid of all thousands of options that we can have also a tiny small description based on XML of CANopen FD devices. There are also plans, for example, for testing the electronic device descriptions. It will be considered in CA 1310-1, which will cover the conformance test plan for CANopen FD devices. A brief summarization on this subject. So CA tests CANopen FD manually at the moment till the availability of a CANopen FD test tool approved by CA. Test cases for manual device testing are published, so under this URL. So we will making the slides available and you can read it maybe much better, and there's no need for the moment to type it down. Furthermore, the test plan CL 1310-1 for a test tool is work in progress. And we have the XML-based device description released, which will be also covered by the test plan. More details on these subjects you'll find also in the presentation from the International Canon Conference, one given by Mr. Kaploon, CANopen FD conformance testing today and tomorrow. And we have a further presentation there dealing with conformance testing and also interoperability testing or simulating. This was given by Marek Schwager, a new approach for simulating and testing CANopen FD, CANopen devices, but this is also applicable for CANopen FD. The specification dealing with the subject you see here in the last bullet point. Finally, we did some further work with regard to network architectures, and an important device class in network architectures are gateways, bridges, routers that allow the information interchange between several network segments. So we had this already for CANopen, for classic CANopen. It's a document here through 302-7. And for example, to allow the exchange of CAN frames, we could use this also for connecting CAN, classic CAN-based networks and CAN-FD-based networks, or in other words, CANopen and CANopen FD environments. So we can do this, for example, on a CANopen base, CANopen PDO base, that we say, okay, every CAN frame that we want to route from one side to the other, we receive with a PDO, map it to our system variables, the shared area, the area of the value range B in my object dictionary, and therefore it's available in all the other ports, and there I map it in a PDO and transfer it. And as I'm using the PDO mechanism, I have my mapping table, and it's no problem for me that I have to differentiate between classical CAN and CAN-FD, and that CAN-FD frames can carry much more data than classic CAN frames, because we see here in this example, okay, according to my mapping table, I break the received data up into certain portions, and I have now the ability to map every portion in a classic CAN frame according to the transmit PDO mapping table of the depending interface. So we see here CA 302-7, never written for CANopen FD, brings everything that allows us to implement a bridge between a CANopen FD and a CANopen, classic CANopen environment. When it comes to routing, we can also analyze the USDO in CANopen FD. CANopen FD brings us already a routing capability in the USDO. The USDO provides an inherent routing capability. We see here a comparison between a local USDO upload request and a long distance routing coded USDO upload request. And we see here this request is enriched now by a destination network ID and node ID and a source network ID and node ID. So I have here a local address, which allows me directing this message to the next router, and the next router, according to its routing table, knows where to pass this message further on. And we see this here in this example. We have here two networks, network 1, network 2, and we see here in our CANopen FD environment, if the device, the CANopen FD device 22 wants to access that device, it sends the routing command, hey, my router device, node ID 26, please pass this message, this request further to the node 12 in network 1, and I'm the node 22 in network 2. So according to the router table that is also defined in 1301, this routing device has now the ability to make here the request in network 1 to address this device, and the address device passes back to the router, and further on the device 22 in network 2 gets the answer. This is already entire content of document 1301, the basic CANopen FD specification. In the International CAN conference, we had a contribution from EMSA, Embedded Systems Academy, and there had been presented a smart CANopen router, which is listening to network 1 and would listen to network 2 and would identify who is present on either side and would update by themselves the routing table so that you have a self-learning router and can establish the cross communication between both networks on either side. So if you want to learn more about this, I will direct you to this ECC presentation. With regard to migration paths, we have also the situation that we need to use something that has already been specified in 302-7, the so-called remote SDO. The remote SDO allows us to inform our CANopen device, hey, this request is not really for you, but on the other side, it is for the other side of your gateway, and please place there the request and make there the access. And this allows you, if you have implemented on the one side CANopen and on the other side CANopen FD, to access via CANopen the CANopen FD side and access there any data element in the object dictionaries of the devices. So this means here we identify via the SDO network indication, which is specified in 302-7, to which network and there to which device, network ID, node ID, shall the next element of the SDO transfer be routed. I can use on the CANopen FD side the USDO to establish this transfer. So this looks like that. I make my SDO request, it's translated to an USDO and transferred back. And as the USDO has the same function coverage as an SDO, I can also do it in the other way. I can request with an USDO something on the CANopen side. No problem for that. But the USDO exceeds the function coverage of the classic SDO. And therefore, I have to also think about such use cases like that, that I want maybe to read a certain data. I have several I/O modules in the CANopen side, and I know, okay, my first 8 digital inputs reside in object 6000. And I say, okay, for all digital input devices, please give me the object 6000. One USDO read on the CANopen FD side, but several SDO reads on the CANopen side. So it takes a while till I get the answer to my request. there is something to be evaluated. I have here a certain delay till I get my final answer. And this may cause a consideration. Should we give some indication that the command is still in progress, that it comes to a delay, that it makes still sense to wait for the answer? So something like that is currently under discussion in the IG CANopen FD. So if you are interested in these activities, I invite you to join the IG CANopen FD and to bring your input. So we have learned once again, there exist people working on migration passes, allowing migrating from CANopen to CANopen FD, and we can use the CANopen to CANopen FD gateways. And furthermore, we have learned in the CANopen FD environment, we are not just dealing with node IDs, but also network IDs. And if you are a little bit listening what's going on in the automotive industry when they are talking about future network architectures, then you have learned that future network architectures, for example, to save cabling and so on, are switching over to a so-called zone concept. All the devices that are somehow located in the very same area, they are collected with one cable independently, whether they are applying to the very same application or not, but you connect them so that you have the data. And then from a virtual basis, you have then to differentiate which devices belong to which kind of application and how to deal with them and how to control them. Something like that we can already do with CANopen FD. We can use our network ID also as a so-called virtual network ID. So if I have one CAN network where several devices are applied, so the black line would be the physical CAN network, I could map via the network ID several virtual networks to this very same physical network. So I can have a virtual network 1, a virtual network 2, and group these devices to 2 different networks and treat them in a different way. So something like that would be possible by using the network ID. It's not a must that all devices attached to the very same physical network claim the very same network ID. You can do by intent handle several network IDs on the very same wire. And furthermore, some people had a certain fear that it might be too stressful for the system integrator to think not only about a node ID, but also about a network ID. There exists also a kind of default value. It's a 0 depicted here. I say, this device is not aware of its own network ID. So it will just answer if you request the 32, the local network, the node ID, which the device is aware of, then it will request to this independent of the network ID value. So there you have to, of course, be a little bit careful that you don't mix it up with other devices claiming network 1, 2, 3. So node IDs have still to be unique in your network. But you see, this network ID opens the door to manage more complex embedded network challenges in the future, or you may already have in your applications. It is a must, an obligation for all CANopen FD devices to be capable, at least in this setup as depicted here, to manage remote accesses. Although it puts a certain requirement on the processing power provided by such a device to the treatment of remote accesses. Therefore, we have at the moment a discussion in the IG CANopen FD how to handle remote accesses and which is the minimum requirement for CANopen FD devices with regard to USDO remote accesses. Which kind of USDO remote access do I have to support? This is the status which is currently written to the CANopen FD specification, which you see now on the slide. And it's now under discussion to make a review and to discuss which remote functionality is really required. So there may be some changes to this table in the version 2.0. If you'd like to contribute, please show up in the working group or give me an indication, and I can invite you to the next IT CANopen FD working group meeting. More details on the subject presented here had been provided by Mr. Pfeiffer from MSR, the Embedded Systems Academy. He provided a simplified classic CANopen to CANopen migration path using smart bridges. We had a webinar given by Alexander Philipp and Thorsten Gedenk from Emota's Embedded Communication, presenting us the migration from classic CANopen to CANopen FD. We have the IG CANopen FD, which is, as I said, currently in charge specifying USD remote service categories. And the specification which is dealing with this is the document 1301. Also, the ICC had shown that we can deal in the CANopen environment with cybersecurity issues. So Mr. Thilo Schumann gave a short recap on the embedded security, and that you have to do some reassessments and which general security controls do exist, what are the threat models, and so on. And Mr. Olaf Pfeiffer and Mr. Andreas Wald from the University of Offenburg, or Mr. Pfeiffer from company EMSA, they showed us achieving multi-level CAN FD security. But what they are showing here is also applicable for CANopen FD, that you do some CAN ID guarding, some deny allow listing, that you group devices together to a group of devices that can share some secure, some encrypted data among each other, and others connected to the same physical wire cannot get the gist of the data. So these things have been presented here. And related information is what was given by the talk from Dr. Christopher Quigley from Warwick Control Technologies in his talk about benchmarking of CAN systems using the physical layer, car, truck, and marine case studies. So he figured out that you can see on the physical signal, on the signal shape, whether a device is sending and which device is sending, and whether a device is missing, or whether another device has been inserted, or whether this data comes from an unintended device. So it had been called also fingerprinting in other use cases. So if you're interested in this, please have a look to these presentations. They can show you some solutions to introduce cyber security in CAN-based systems, also applicable for CANopen and CANopen FD. Yeah, this was a short wrap-up about CANopen FD update. What are latest movements with regard to CANopen FD? If you have inspected some insights to CANopen FD, how CANopen FD works in general, this we had already on a previous webinar. So just go on our YouTube channel, and there you will find also CANopen FD introduction webinars. Furthermore, I like to invite you to our working groups. So the IG CANopen FD is currently updating 1301, the basic CANopen FD document with regards to 40 megahertz based bit timing, the USD remote services, gateway functionality, security, and so on. We are dealing with some CANopen FD issues in document 1301, as explained, the LSS specification, conformance testing 1310, device description 1311. There are still some extensions planned. We are adapting the well-known device profiles with regard to CANopen FD. So there, the ID profiles is in charge. If you are interested in this, please give me a call. And very new, very fresh, we're intending to start the definition of our CANopen FD security layer. Yeah, so much for the moment. You see, the history of CANopen has not been written yet. See our working groups on work on various issues, and keep CANopen FD meeting the requirements of embedded networking. The ICC provides, in this context, a lot of interesting papers focusing, among others, on CANopen FD. And if you want to get full access to these papers, please register for the ICC videos and proceedings at can-cia.org/17th-ICC. For them, I can give you some additional information. So for being updated, please register for our email services, which appear monthly, the info mail for non-members, the CIA member news intended for people that come from Canon Automation member companies. If you want to discuss latest Canon-based issues, you can hopefully meet us once again on the SBS in Nuremberg or other fairs that will hopefully take place in the next year when we have overcome the Corona pandemic, hopefully. You can learn some more about certain issues. We have CANopen FD Technology Day, end of September. We will have another day if you have some Russian colleagues in Russian language, mid of October. And you see here, we continue our webinars. So here's the latest update on our webinar plan. So the next will be tomorrow, also on CANopen FD, but in Russian, in Chinese language. So if you have there some colleagues, you can inform them. I think it will be more a basic webinar on CANopen FD. And furthermore, you see other subjects like profiles 401, 402, motion control, CAN XL, the next generation. So I hope a lot of interesting topics are upcoming, and me and my colleagues appreciate meeting you once again in these webinars or on other occasions and informing you on ongoing trends in CAN-based networking. So much from my side. You see here furthermore our contact data. So I thank you very much. For those of you in Europe, have a great evening. For the others, have a great day or night. And see you next time. Stay healthy. Bye.